All right, so we have a couple more terms for you and a couple more examples to use those terms and kind of drive them into your skull. That's not really quite the vibe I'm going for, but if it works, it works. So we're going to talk about a couple things here. To start, we're going to talk about parameters and statistics. Okay, so parameter is what goes with the population. Okay, parameter is attached to population. So we're talking about population, we're going to use the word parameter when talking about data, when talking about our results. And statistics are going along with samples, which again, so a statistic is always going to be referring to a subset of the population. Okay, whereas a parameter is always going to be referring to the whole population. And then depending on whether it's categorical or numerical, that'll affect whether what we talk about is a proportion or a mean. So let's start with categorical. Okay, when we're looking at data for categorical data, we're getting usually words, but sometimes ratings or identifiers, could be numbers as well. But a lot of times it could be even like a thought process. Categorical could be, do you support this new measure that is being voted on? Okay, and categorical is going to be yes or no things. How many people gave a rating of 3 or higher? Well, did you give a rating of 3 or higher? Yes or no? When we talk about data, that's what these parameters are going to be. That's what these numbers are going to be. Okay, so even though categorical data can sometimes be words or not numbers, when we're talking about analyzing data in this fashion, these are always going to be numbers right here. Okay, and these down here are going to be proportions, so a number between 0 and 1. And these down here are going to be means or averages. A lot of times we will say average instead of mean. We'll say mean sometimes when we mean average, and okay, never mind. Okay, all right. So proportion has to do with categorical data, and we'll use the words P, the letters P, or P hat. That's how it's pronounced, and it's just a P with a little hat. If you want to look at it bigger, that's what it looks like. A little caret on the P, and we call it P hat. This down here is the Greek letter mu. All right, it's written like that, and it's pronounced kind of like the Pokemon. And this over here is X bar. And again, it's just an X with a big bar over it. Okay, so these are variables that we're going to use very, very frequently. Let's do an example to kind of reinforce. That's the word I was looking for, reinforce, not drive into your skull. So we have some researchers here, and these researchers are interested in the percentage of people in a city that support a new recycling law. So as soon as we see percentage, it's not guaranteed, but percentage is probably going to be a proportion. The people that support a new recycling law. Do you support a new recycling law? Yes or no? We're going to be dealing with a proportion. All right. So as soon as we know that, we know we're going to be talking about a proportion. So it says draw and label a picture to represent the kind of like what we did in the first video: population, sample, parameter, and statistic. So again, the population is everybody. So all the people in the city. All right. All the people in the city, that's going to be our population. And specifically, we don't know P, right? We don't know what does everyone in the city think. We can only ask some people. We don't know P, we only know P hat. We can only take a sample. We cannot ask everyone in the city probably. Okay, so this true proportion, the population proportion, P, ooh, lots of P's here, is unknown. We don't know what all the people think. We can only ask some people. Okay? So specifically, we have this, small subset. This is going to be our sample, the people that we ask. All right, let's do sample in a different color. Let's do red. This over here is going to be the sample, the people that we ask. All right, and we are going to know what p hat is. P hat says for the sample, the people that we're asking, what is the proportion? So we do know p hat, sample, statistic. Oh, population proportion. I also forgot parameter. There was another p. Parameter population proportion p. We do know the sample statistic proportion p hat because we're asking them, we are getting a response, and there we go. So we've answered, we've talked about the population, sample, the parameter, and the statistic right here. And again, we don't know the values here for the population, and the problem didn't even give us what p hat was, but maybe p hat was, I don't know, 58%. And maybe the actual percent was much higher. Maybe it was 0.67. Because maybe we only asked people where it was like in a more unpopular area, people that didn't want to recycle or something like that. But in reality, the actual population is different. We almost never know the actual population parameter. Okay, this mu and p, these are very hard to find in practice. And so a lot of what we're going to talk about later on in this course is the relationship between the sample statistic, which we can find out, and the population parameter, which we don't know. Okay, and that's going to be one of the big things that's coming up in this class. All right, and then we have something very similar over here. Researchers are interested in the average days of shelf life. As soon as you see average, think numerical, okay? Not a parameter anymore. We're going to be thinking about means or averages. So average days of shelf life for an apple at Trader Joe's in Olympia. Draw and basically do the same thing as the last problem. So again, we still have this population. That's not how you spell that. Nice try, Jason. Population. All right, the population is going to be all the apples. Everything that we want to be able to ask all the apples. I guess we're not asking them, measuring them. You can ask or measure. We want to be measuring all the apples at Trader Joe's in Olympia. So all Trader Joe, I don't know what happened to that word. All Trader Joe apples in Olympia. And who knows? That would be the parameter. That would be the true average, mu. All right. Parameter is a mean. And mu is unknown. We don't know. We just don't have the time or maybe the interest to measure the shelf life of every single apple in this Trader Joe's. All right. Maybe we could. Who knows? And in reality, what we're going to measure is a small subset. That's going to be the sample. Right. And so that's going to be maybe some of the apples. Okay. And how we choose which apples is something from a future video. It's coming up real quickly now. All right. And then so the statistic is the value, this average that we actually can measure. is going to be X bar. Okay. And this is, we can measure this. All right. So that's the parameter, statistic, population, and sample here. And that's the video. Good luck.